All right, folks, this is Mr. McIntosh here to help you out with some inverses today. So check out what we're going to do. First off, let's talk about inverses themselves. How do you know if something's an inverse? Well, there's two different ways. You can either take the x and y and flip them and solve for the inverse, or solve for y. Take one equation, plug it in the other, and if you end up getting just an x, guess what? It's an inverse. So let's show you both ways. First off, what if I take this x and f of x and switch it? So instead of saying f of x, we say x. All right, so I switch the x and y's, but let's solve for y. So I want to subtract 3 from both sides. So I get x minus 3 equals 2y. And then if I divide by 2, guess what? If it turns into the other equation, then they are inverses. So I look over here, bam! Are they the exact same? Yes. So if they're the exact same, then you would say yes, they're an inverse. But there's another way to do it. Let's try a different way here real quick. What if I take this function here and I plug it into this one? If you take one function and you plug it in and you end up getting x, then you do have inverses. So let's try this out. So if f of x equals 2, but instead of x, I'm going to replace it with this function. So now I've got x minus 3 over 2. That replaces the x, and then I do plus 3. So let's see what happens here. Well, I have a 2 on top and 2 on bottom, so they cancel out. So then I have x minus 3 plus 3. And then no need of parentheses, there's nothing to distribute. So x minus 3 plus 3. And lo and behold, the 3's cancel. And so what I'm left with is f of x equals x. So if you end up with just x only, then guess what? They are inverses. So there you have two options. Either plug one function into the other. If you get x, it's inverse. Or flip the x and y, solve for y, and if you get the other function, guess what? It is an inverse. So let's check out some practice work. All right, folks, so here we are. Here's your assignment. You're going to have three different parts. Either state yes or no if they are inverses by showing your work, finding the inverse, and then finding the inverse and graphing the inverse. And if you can do all of this stuff, then bam, you are going to be really good at this. So let's check out number one. Now, number one, I've got cubed, I've got to the 5th power. To me, I can personally see there's no way I can go from a cube root to a power of 5. So automatically should know that it's a no, but let's just try it anyways. So if I do, how about to the 5th power one? What if we take this right here? So I'm going to take this one and I'm going to show you one way. Let's just flip the x and y. So if I say x equals y to the 5th power minus 3. Now I need to get y by itself, right? So if I add 3 to both sides, I end up getting x plus 3 equals y to the 5th. And to get rid of the 5th power, you know, you could go to the 1/5 power, or you can 1/5 power. And so the 5's cancel. Now look, folks, x plus 3 to the 5th power. That's x minus 3 to the 3rd. Are they the same? Definitely not. So that's automatically a no. Okay, so that's one way to do it, and pretty simple there. But let's go ahead and jump on number 2. Now number 2 is actually kind of fun, I believe, because instead of flipping x and y, let's try plugging in. So what if I take all of this and plug it into this? Let's give it a shot. So now I have negative 2 times, man, the 5th root of negative x minus 2 over 2 all to the 5th power minus 2. Now what's nice about this one is when I do it, guess what? The 5 and the 5th power cancel out. So then I end up having negative 2, and what's left in the parentheses is negative x minus 2 over 2 minus 2. And I can see that the 2's, well, let's change color here. These 2's cancel. And I can distribute my negative, so that's going to be a positive x. That's a positive 2. And then I'm left with negative 2. And guess what happens? This 2 and that 2 cancel, and I'm left with x. In this case, it'd be g of x. So if I plug one function into the other and I simply get an x, then I have a yes. See how that works? So they are inverses of each other if I can plug it in and get just an x. Or it's not an inverse if, say, I get x, switch x and y, and I solve it, and I do not get the other equation. If they don't equal, then guess what? They're not inverses. If I plug it in and I get something like, for instance, let's say I get f of x equals 2x plus 5. Well, if I did my inverse and I plugged that in and I got something like that, it's not x, so that would not be an inverse. Okay, so that's how you do those types of problems. And guess what? We just did 2 of them, so you have 8 left on this page. Let's go to the next page. All right, I wanted to try problem number 14. So everybody take a look at problem number 14. Okay, we have 2 different ways to find the inverse. On this second page, it's just strictly saying, hey, find the inverse of each function. So I have g of n. The first way, I guess the only way to do it is let's flip the n and g of n, right? So if I take this n and I'm going to put it as n equals instead of g of n, I'm going to put -2. Now this case it's going to be to the 3rd power. Okay, so it's an inverse, so it's to the -1 minus 2. All I have to do is now do reverse algebra, getting g of n by itself. So first thing I would do would be to add 2, right? So I'm going to add 2 to both sides. So I'll get n plus 2 equals -2 g to the n cubed. All right. Now in order to get the g to the -1, so I'm going to divide by -2, divide by -2. And I personally don't like negatives on the bottom, so I'm going to redistribute on top. So I'm going to get -n minus 2 over 2 equals g to the -1 n to the 3rd power. But I'm almost done. I just need to get rid of that cube root, so, or cubic, so I'm going to cube root both sides, and there's my answer. So technically I could say the inverse of g of n is the cube root of -n minus 2 over 2. I'm going to check my answer key just to make sure, and on my answer key, that's what I have. So again, you take this, put it there, you take this, put it there, and you solve for your inverse. That's how you do page 2, simple as that. Good luck. Let's go to page 3. All right, I'm going to go ahead and do number 23 with you. So everybody look at number 23. We've got cube root. All right. So looking at cube root, I need to graph this bad boy. So I'm just going to come over here. Okay. Get my table. We're talking about g of x, right? I'm going to pick 4 points. How about, what if I did, I want to start off with, how about -1, 0, and 1. How about those, just for fun? So if I plug in -1, I'm probably going to get -3. Okay, because -1 plus 1 is 0, 0 cubed is 0, minus 3 is -3. I plug in 0, I get 0 plus 1 is 1, 1 cubed is 1, 1 minus 3 is -2. And if I plug in 1, 1 plus 1 is 2, 2 cubed is 8, 8 minus 3 is 5. Let's go ahead and plot those points. So back 3 down, or back 1 down 3, 0, -2, and 1, 5. 1, 5. And because it's cube root, we know it's going to probably look something like this. We're going to go blue. Hold on a second. Let me go back right there. Yes. Okay. So it's going to look something like blue. Come on, man. All right. Right here. Bam. All right. There's our cube root function. Looks so pretty. Now, what's really cool about inverses, okay, is if I'm trying to find the inverse, let's do the inverse of g of x, then what you're going to do is your x and y's flip. So technically, -1, -2, and -5, or not -5, +5. My y values in my other function are now my x values. And if it is a true inverse, my x values are now my y values. But in order to do that, let's mathematically show that that's true, because if I do that correctly, let's just graph this. Back 3, down 1, back 2 to 0, over 5, up 1. So if I do this correctly, it should look something like, let's see, probably something like, all right. Man, bam! I'm big baller shot caller on graphing, but let's mathematically see if that's correct. So I'm going to bring this over here, and what if I switch the g of x and the x? So if I solve for x, then we put g negative 1x plus 1 to the third power minus 3. Let's see how this works out. So first I'd move the 3 over, so I get x plus 3 equals all of this, plus 1 to the third power. But I got to cube root this mug, cube root, because that and that would cancel out. So now I'm left with the cube root of x plus 3 equals g to the negative 1x plus 1, but I get rid of that plus 1, so I got to subtract 1, subtract 1. So technically, let's move this down here. My g of negative 1x should be the cube root of x plus 3, all of that minus 1. And if you remember your transformation properties, check this out. The plus 1, you do the opposite, moves it back 3, which it did. The minus 1 brings the graph down. You see how that is? The cubic turns it sideways. Whoa! Holy smokes. But let's just check our mathematics. You want to check the math? Let's see. How about, for instance, negative 2, 0. Let's see how that works. So I plug in negative 2. Negative 2 plus 3 is what is that? It's 1, right? And then the cube root of 1 is 1, and 1 minus 1 is 0. Bam! Holy moly. Even try a negative 3. Negative 3 plus 3 is 0. O's, the cube root of 0 is 0. 0 minus 1 is negative 1. Bam! So we showed it graphically, we showed it mathematically, so you have it, folks. All you have to do with inverses, switch the x and y, solve for the new y, and you have your inverse. And remember, back on the front page, if I plug one function into the other and I end up solving and get only x, it is an inverse. All right, you have video. Go back and watch anything on this video you'd like to watch, and good luck on your inverses. Peace out.